Alright, here's the screencast for 8.2 part 1, vectors in a coordinate plane. So, first, the component form of a vector, you use these triangle brackets. It's always your x, comma, y, and their brackets, because it's a vector, so I always think arrows, vectors. Alright, so let's say you have your starting point and you have your end point. Right, so the change in x is x2 minus x1. That's how you can find the how long is our resultant x, and then define the change in y, right? Y2 minus y1, right? That will tell you how long your y is. Define how long your x is, x2 minus x1. So, for example, let's say I have a vector 1 comma 4, and then my other vectors at 1 comma negative 2. Right, so what I would do is I'm trying to subtract them. So I'm taking my second point minus my first point. So this is going to be 1 minus 1, comma, oh my gosh, 4 minus a negative 2. So this turns into a vector that's 0x long and 6y long. Okay, so this is component form because it tells you your x component and your y component. It breaks it down into two parts. Let's find the component form of vector a to b with initial point 1 comma negative 3, so that's my x1, here's my y1, and terminal point 1 comma 3. So this is my x1, here's my y2, sorry, x2, y2. Okay, so I'm going to draw this out just so you can see. It's not evenly spaced. 3, 1, 2, 3. Okay. And then at 1, so I have a point A, which is at 1 comma negative 3, which is right here. Here's my A. My B is at 1 comma positive 3. So my vector is going from A to B, right? Because it's going from A to B, where you start to where you end. So what I would like to know is the component form of this vector. So you can see it's all vertical. So to find this, you do x2 minus x1, comma, y2 minus y1. So this is just going to be 1 minus 1, comma, 3 minus a negative 3. So our vector form is 0, comma, 6, which makes sense because it's 0x and positive 6 in the y. We're going up 6 in the y. Since magnitude of vectors is represented by its length, it's found using the distance formula, aka Pythagorean theorem, right, where you use the square root. This is your x squared, this is your y squared. Oh my gosh, you can't even read it. This is your x squared right here, because it's your change of x, and then squared. This is how long your y is, and then square root finds the magnitude. It finds the length of your vector. It doesn't tell you direction though. Literally, it's your x squared plus y squared equals the resultant squared. So in order to solve for the resultant, you take the square root of x squared plus y squared. But wait, how do you find how long your x is? Oh yes, x2 minus x1. Alright, so this is your x, this is your y. Find the magnitude of vector AB with initial point A, 1, 3, negative 3. Oh, it's the exact same vector. Okay, I want to know how long is this. So I take the square root of x2 minus x1 squared, and I'm going to add my y, which is y2 minus y1 squared, and then take the square root. So the magnitude, how long vector AB is going to be, let's see, the length of AB, vector AB, is going to be 1 minus 1 squared plus 3 minus negative 3 squared. You know, this is the exact same problem we just did, but it's okay. So this is equal to the square root of 0 squared plus 6 squared. So it's just going to be the square root of 36, which is just going to be 6. So the magnitude is 6. This doesn't tell us which direction it's going into, but tells us how long the actual arrow is. So, addition, subtraction, and scalar multiplication of vectors resemble that of matrices. So, you can add vectors together. You just add their x's and you add their y's. You can subtract two vectors, but you have to subtract corresponding parts, right? Subtract the x from the x and the y from the y. And then scalar multiplication, all you have to do is multiply both the x and the y by whatever number this is. So, for example, find each of the following. blah, blah, blah. Okay, so 2 times w. So it's going to be 2 times my vector w, which is 2 comma negative 5, plus my vector y, which is 2 comma 0. So the first thing I'm going to do is distribute the 2. So multiply it out, 4 and negative 10, and then I'm going to add, right, this is my vector y. I distribute out the 2 and then I'm going to add. So now we just have to add, I add my x's together, and then I add my y's together. You have to add like corresponding parts. So 4 plus 2 is 6. I'm going to use a different color. Comma, negative 10 plus 0. So my overall vector is going to be 6 comma negative 10. Now let's try the next one. So 3 times the vector 2 comma 0 minus 2 times the vector, let's see, z negative 1 comma negative 4. I'm going to distribute out a 3, and I'm going to distribute a negative 2, that way it's adding. So 6 comma 0, adding 2 comma 8. So add corresponding parts. So add the x's together. 6 plus 2 is 8. 0 plus 8 is 8. Add corresponding parts. Corresponding. Cool. And then that's it. Alright. A unit vector is a vector with magnitude 1. Consider vector v. A unit vector u will have the same direction by a magnitude of 1. Alright. So v may be 2.5 long, but the unit vector literally, is only 1. I don't know if you read it, absolute units, it's like the 1. So we're going to find a unit vector that has the same direction, but the magnitude, the length is only 1. Okay, find a unit vector u with the same direction as v, right, of 4 comma negative 2. So this is my x, this is my y. So first step, I want to find the magnitude, the length of v. So in order to find the magnitude of my vector v, I just do a squared plus b squared, the square root, because this is Pythagorean theorem. So also square root of x squared plus y squared. So this is going to be the square root of 4 squared plus negative 2 squared. That's going to be the square root of 16 plus 4, so that's just the square root of 20. And you can simplify this and say 2 root 5. Alright, so what that means is, and it needs to be the same direction. Okay, so let's go ahead and let's draw a picture, right? So I know the length is 2 root 5. I know the x is 4, and I know the y is negative 2. Oh my god, this is not to scale at all. Whoa. So 4, negative 2. And that means that my vector, let's see, the resultant is 2 root 5. So remember, this is the length of my vector. I want the length to be 1. A unit vector has a length 1, right? So here in our example, our vector v has a length of 2 root 5. I want my vector to be length 1. So in order to be a length 1, I just have to divide by 2 root 5. So I'm going to take all of my sides and divide by 2 root 5. Okay, so divide by 2 root 5, divide by 2 root 5, divide by 2 root 5. Okay, so that turns into, so my hypotenuse is 1, 4 over 2 root 5. Okay, let's see. Yeah, dividing all by 2.5. Okay, 2 root 5. So this is our second step now, right? We're going to divide our vector. Sorry, I just got a little lost. Okay, divide our vector by the magnitude of our vector. Divide each of our components. So that means I'm going to take my vector 4 comma negative 2, and I'll divide each of those by 2 root 5. Yeah, this is a little more organized. So what this means is 1 over 2 root 5 times 4 comma negative 2. Such as 4 over 2 root 5, comma, negative 2 over 2 root 5. Simplify this out if you want, right? So I can write this as 2 over root 5, comma, negative 1 over root 5. right? Because the 2, that goes away and makes a 2, that cancels out, it's just negative 1. Or I could write it as this, right? So if you rationalize, you could write it as 2 root 5 over 5, comma, negative root 5 over 5, right? And this is my unit vector u. So notice the unit vectors are in the same direction as the positive. So talking about unit vectors with length 1, you can have a unit vector I and j. I is a unit vector in the x direction with length 1. J is a vector only in the y direction with length 1. So you can actually use these unit vectors to represent any vector using I and j. So this is what the screencast next time will be about.